Online students, am I audible to you? So those who says good evening, I am also saying good evening. So now let us move to the further. So I'll go to the further things now. So last class we already completed how to create threads, how to create subthreads, and how they works. Threads, if you go, these are the module name required for developing thread-based applications. Module name is threading. Functions in threading module is current underscore thread and active underscore count, and next active underscore count, and next event thread of target comma args start get name and set name is underscore alive join. These things we already discussed it. Okay, so coming to number of approaches for development of thread-based applications. Number of approaches for development of thread-based applications. Two approaches are available. What are the two approaches? One is by using functional programming, one more by using object-oriented programming. When I am asking question, they are replying. You are not replying. How many approaches? Two. Functional programming, object-oriented programming. Last class, we discussed steps and did some examples on that area. Okay. So next, I'll go for today about another concept. Last part of the threading, we come to that. This part, deadlock occurrence, synchronization, this part I will discuss. Shall we start up? Well, now coming to point back to here, we are going to enter into the concept of deadlocking concept. Take care, students. Small program I will write it. Here I am going to write program for direct. I'll go to the example. Through example I want to discuss, and before that also I'll say program for demonstrating deadlock occurrence in the program. So the deadlock occurrence with the functional programming and object oriented programming I'll show you, and whether you will understand this deadlock occurrence direct program or not, I don't know. So first, because I don't want to make experiment with you, because you are small kids, I'll give first example. For normal example I will give you model 1. I'll try to give this example model 1. Okay, students, model 1 example what I taught to you. In the model 1 example I taught to you related to like this: T1, T2, T3, T4 are called what? Are called subthreads. Very good. Who said? Good. Really good. Who said? Believe me, my dear students. Really correct. These are called subthreads. These are called subthreads. Who said? So correct. Because I asked the first time, not answering. Here, these are called subthreads. Each subthread is having their own function is available. Every subthread is targeted to what? Some function. So this is called X function. This is called X function. This is Y function. This is Z function. Z function. This is a K function. This is a K function. These are the various functions we have. This is X, Y, Z. These are the functions we have. Right? We say what, T1 dot start, T1 dot start, T2 dot start, T2 dot, yes only I am writing. T3 dot start and T4 dot start. When you say start, what will happen? T4 dot start. What will happen when I write a T1 dot start, what will happen? When you say dot start, T1 dot start, T2 dot start, and a T3 dot start, and a T4 dot start. When you say dot start, they are entering into the corresponding target function. They are entering into the corresponding target function and will get the result. Will get the result. So here we are getting the result of this X function, result of Y function, result of Z function, result of K function. So we are getting X result and RES. Again here RES. Here again you are getting RES. Here again you are getting RES. So these are the things we got it. These are the things we got it. Right? This is called model number 1. For each thread, this is called 1:1 model. One thread object is to one function or one method is available. That is what is our multiple threads creation says. This is a 1:1 model. This is nothing but what? 1:1 model. That is a model 1 example. This is what you have seen in our present picture. Present programming is that only. So this is nothing but what the example which I said to you so far. Understood this part? So now next part is called what you know. Next part is called what you know. This is one thing. This is 1:1 ratio. There is no problem. Everything is safety result will come. This result is known as what? Thread safety result will come. Safety result will get thread safety result. Thread safety result is coming because there is no interference of one thread in another function. One thread corresponding function. One thread corresponding function you are getting it. So this is going to give you which result? Thread safety result. Understood? Now, model number 2, online students, model number 2. I'm talking about model number 2. What is this model number 2, students? Very, very easy. In this model number 2, do you know what is happening, students? Ramesh, my dear student. So, you are working like an elementary school T4 dot start like. So when teacher writes something wrong, you'll say, teacher, there's something teacher, there's something teacher. Until I change it, because you're all professionals. Even if I write something 4, you have to understand T4 dot start. So, Ramesh, is it okay? Shall I move to the further? Shall I move to the further? Ramesh, are you there? So, he's memorizing which school I studied, he's thinking like. Now I'm going to take up T1, take care, T2, T3, and next is T4. These are my threads. These are my threads which I'm taking. Be careful. Try to understand all of you. T1, T2, T3, T4. These are all called different threads. Then, in this context, I would like to ask you a question. In this case, what I'm asking is, when you say for all these things, the code written here is T1 is equal to thread of what I'm writing, target is equal to some function name called X. That's all. X. I'm writing just like a X. Now, X or something like, something like fun function. Next, I'm taking one more kind of thing, threading dot. One more kind of thing, T2 is equal to same. All of them are same target function, students. All of them are called what? Same target function. Carefully try to follow. Next, I'm going to take up here T3. T3 I am going to take up. Like the T4, all of them carefully observe it. How many threads I am having? 4 threads are created. All of them are target to what? FUN only. So here I am having a common function is available. DEF FUN of some block of statements written. Some block of statements written here. Some block of statements. Some block of statements written here. So observe students, some block of statements written. So this indicates a common function. This is one function. This function contains a thread processing logic. What you did here, T1 dot start you set, T1 dot start you set, T2 dot start you set, T2 dot start you set, T3 dot start you set, and T4 dot start you set, T4 dot start you set. Because of this, what is happening? Because of this, what is happening? T3 dot start, T4 dot start. Because of this, what is happening? These threads, all of them, targeted to the same function, all of them are going to where this function only they are entering. T2 also entering into the same place. T3 also entering into the same place. T4 also entering into the same place. And finally, PVM is entering. The 4 flows are entering inside only. How many threads are there inside of the inside of this function? 4. T1 is there, T2 is there, T3 is there, T4 is there. All of them are executing inside the function. Which result you can predict it? T1 result or T2 not T3 not T4 or can't predict. We can't predict the result. We can't predict the result. Such results, we can't determine the output. No expected output will come. This is known as what? Non-thread safety result. Non-thread safety result. Non-thread safety result will come. Non-thread safety result will come. Such a type of non-thread safety result is called what? Deadlock result we can call. Deadlock. Deadlock result we can call. This result is nothing but wrong result. Wrong result. Non-safety result is nothing but wrong result only. In simple word, I feel that you understood this. Still, if you did not follow, I'll take a little another example. Take an example of this is called what This is called one. This is like this. I'll take. This is called one road. This is called another road. This is called another road. Still, if you did not follow, this is called another road. This is called another road. And this is called another road. This is called another road. What is this area is called? What is this area is called? What is that? You don't know. What is that? Junction, na? Is a intersection area. So this side vehicles are coming this place only. This side vehicles are coming. All the vehicles are coming to this place only. This is called intersection area. And if all vehicles are coming at the same time, that junction area, something will occur or not? That is not a correct result. That is called a wrong result. How to avoid that? What concept is applied? What concept is applied? What concept applied you are seeing in the lifetime? Traffic signals are applied or not? Red side, people will wait. Other vehicles are going. That is, red will come. Other vehicles will pass. That is called synchronization. All of them came, but allowing at any point of time, some vehicle only allowed. Other vehicles stopped. When the timing is over, these vehicles will pass away. That is why they are avoiding the non-safety results. To get the safety results, which concept is applied? Signaling concept applied. Such a signaling concept in programming is called avoiding the deadlocks. avoiding the deadlocks. So traffic signaling, controlling traffic signaling mechanism is called synchronization concept. In traffic signal, the light is there, na? ATC, word is coming. Automatic traffic controlling. You're actually a gold medalist, full formula, but you don't know. Whenever traffic signal is coming, you'll open immediately WhatsApp, seeing like this. And like that. So that type of code, how to write that chip level coding, the timing and all those things is done with the threading only. 60 seconds, 140 seconds, 144 seconds, depends on the traffic flow. They can set the timing also. Did you understand? What is synchronization? What is synchronization? The process of allowing one thread at a time into the intersection area to perform the operation to get which result? Consistent result, safety result by avoiding deadlock result is called synchronization. Understood? So, is going on the bike. One person is going on the bike. Is a bike. One person. Wrong result. So, no voice. So, voice gone. So, no, my voice is here. So, now, my dear students, no. So, no patience at all. Sometimes this is a net now, internet now, because these days we cannot expect the answer from you people immediately. But how can you expect a 24 hours voice? Anyhow, did you understand this concept? So what is the synchronization says? This is a T1, this is a T1, this is a T2, this is a T2, this is a T3, this is a T3, this is a T4, this is a T4. All the threads want to enter at the same place. Definitely gives what? Wrong result. To avoid this wrong result, which concept is coming? Traffic signaling is coming. How to write the coding in Python? That is called the meaning of what? Synchronization. So synchronization is coming into the programming to avoid which concept? To avoid the deadlocks concept. To avoid the deadlocks occurrence, we are using which concept? Synchronization is a concept of OS, operating system. One topic is available. Synchronization. Anybody studied OS here? CSC students here? MCA, OS, deadlock occurrence, deadlock avoidance, mutual exclusion, Banker's algorithm, semaphores, monitors, producer consumer problem, readers writers problem. Any MCA students here? No, because they are just keeping silent. I know, because when I'm saying all these things, their signals are changing. I can easily find out. Two students I found out, MCA students. BTech students, they don't show their signals because they're in. So smart. MCA students, they're little elder than them. They'll show some correctly. Okay. No problem, students. That are all examples of what? Synchronization. Let us coming to the point of it. Last and final, I am going to say. Last and final. I hope by this time you must understand. Last and final. Take an example of IRCTC project. IRCTC. Do you know this? Railway Reservation App. You want to visit in the train number so and so. You want to allocate. You want to reserve a berth. We want to reserve one berth. And you are trying. I am trying. Somebody trying. Somebody trying. Somebody trying. So many requests can go to the same to reserve it. What is the your IRCTC server should do? Server should do. Whichever request will come first, that thread will be allowed to do it. If it is confirmed, it should be showing the blocked sign for other people. Try next. Suppose instead of that is known as what? Applying what concept? Synchronization concept. Instead of that, no synchronization concept is applied. If four people are trying, four people are given reserved this berth only. What happens? Night they will go, and this berth already one person is there. He will go, all the people will go. And the same time is there. Same hour, same minutes, even not showing the milliseconds of time in the railway ticket form. Only hours and minutes is shown. In the same hours and same minute, in seconds of time, that reservation is done. So in this case, what is happening? Will the four people will sit at one place? Huh? No. That is giving you what? Deadlock result. Okay. Still, if you did not understand, your college is conducted a running competition. This is a runway 1, runway 2, runway 3, runway 4. Is a person running in this way? Is a person running in this way? Running in this way? Running in this way? It is a 1:1 runway is prepared, no problem. Another runway is what? This is another runway is what? They prepared a common runway, and here many of the people, many people they called many people. What happens? They said 1, 2, 3, start. All of them are trying to enter into the single runway. There is a chance of falling down some of the people. That is known as what? Deadlock occurrence. To avoid that, what is happening? When you are hot, always you are chill. That's why no answers are coming. It's okay now. Now it's okay. Is it coming? Shamsuddin is asking. If sir is explaining for 2 minutes, chill will go and Is it okay now? Is it okay, students? Is it clear? Okay. Point by go to further. Now, students, deadlock occurrence, I am going to write the coding. Go for deadlock DEF MUL table of N. MUL table of N. There I will write it. If N 0, I am writing input I will this. Format of voice is breaking. Voice is breaking. So today there is a lot of problem with voice, sir. So now coming and going. Was also buffering, sir. Okay. Now it is okay. So coming to this, voice is breaking. HOLIDYA is in holiday only. He is in holiday. He is completely chill. So my problem. మరి సాల్వ్ చేయాలి కదా. Students, today some problem is coming. Is it okay, students, now? Shall I continue now? No, rejoining again, it will take a lot of time, students. 1 minute, you hold on. Here I will write it. Print of. Now I'm going to continue this. Multiplication table for, I'm going to give you the multiplication table. Multiplication table for so and so number I'm giving. Yeah, I'm writing. And I'll write the thread name also here. Thread name also. This I will write it. Format of, write it. And so done. And I'll write for I. This thread I will write it. And I'll write the multiplication table, student, into is equal to dot format of dot current thread dot name I will say comma n comma I comma n into I. So coming to this place. So again same problem. Stop carefully. This is breaking again. So my time is my schedule is solving problem and voice problem. Kankapani, your voice is amazing. Okay. Problem. Look at that carefully. Main program I'm taking. In this case, I'll write it. T1 is equal to threading dot. I'll write it. Threading dot thread of target is equal to MUL table. Args is equal to say 16th table, comma. T2 is equal to having here T2 is equal to threading dot MUL table of some 19. Next I will take it T3 is equal to MUL table of what you know, 6th table, something like you know, 9th table you take it. Now these are the tables are created. Dispatch the threads, dispatch the subthreads, dispatch the subthreads, dispatch the subthreads. How do you do the subthreads? T1 dot start, T1 dot start, T2 dot start, and then T3 dot start, T3 dot start, 4 dot start. T1 dot start, T2 dot start, all 4 threads dot start. All of them are entering into where target function. What is my target function? Is coming. All of them are in. That's the import thing. So down. So listen properly. So don't keep the thumb down in your life. Always say thumbs up. So because of the networking, I can't do anything, you can't do anything. You ask this Government of India, Act of FiberNet to provide this networking like this. So in the wait for 5 minutes. Online. Hey Rajneet, what are you doing? Naughty boy. Wait for 5 minutes. Online students. Start. Dot start. We'll say T1 dot start, T2 dot start, T4 dot start. When all of them are started, they will enter into this place and will get what result? Unexpected result will come. That is called non-thread safety result we can say. As I was mentioned here, non-thread safety result will come. Non-thread safety result will come. So execute it and try to find the result. So see that, go to the place and run as an administrator. Look at this carefully, students, all of you. Now I'm going to see. Here I'm going to take up E colon, go to the location, Python here, 6 p.m. Say here threads. There you observe it, py, and this example part. That example is deadlock function example dot py. First save this program now. Done. Go to this place. Py. See this now. Answer is time is not defined. Import that module also. Threading also done. Execute it. See the answers now. You are going to get it. The answer is called what? Thread 1, thread 2, thread 3, thread 4. Some result is coming which is not at all useful. all the mixed result is coming. This result is of no use. This result is of no use. 16, 19, 6, 9. All 4 threads started. Because of this result, there is no use of that. That is known as which result I said. That is known as which result I said. Non-thread safety result we can call. We call that situation as what? Deadlock result. How to avoid that? That I am going to tell you in the class. This is the deadlock occurrence using functional programming. Understood? Is it clear? Let us go to the same thing. Here I am going to take up others here. I am saying Python here. So I am writing instead of functional thing, I am going to take it as what? Object oriented programming. So OOP, now I am taking deadlock occurrence OOP example.py. So OOP example.py. There I will write it what? Class. Now I am writing here MUL table is a class name. MUL table is a class name. In the I'm taking function name I am taking called what? Table, comma. What I am doing? Self, comma, n. This is known as instance method. With there, how we are going to get it? Similarly, MUL table dot, already I taught in the last class, nameless, I will use it of. Similarly, same function name I will write it. In the case of non-thread safety, what we written? Different functions we written last class. And also everything targeted to what? Same function only. Everything is targeted to the same function. MUL table of table, MUL table of table, everything is targeted to the same function only. So all the threads are entering to where? Same function only. Let us execute. Let us execute this now. Go to this place. Save this now. Object oriented programming. Go to the place. See the result. Got the output. Same output is coming here also. That means either in functional deadlock result will come or in object oriented level deadlock will come. How to avoid this is my next step. There I am applying which concept? Which concept I am applying? Synchronization. Did you understand? Online students, I hope with my simple coding part, I am showing this is a deadlock result in functional. This is an object oriented programming, also called what? Deadlock result. Now I am entering into other part of it. So students, I am going to enter into the how to avoid that. As we discussed already, module name for developing thread-based application. Last class we discussed about what? Class name 1 for threading module, thread plus. I am discussing about another class here. So here, so here I am going to write it. Class name 2 in threading module is called what? Lock class. Yesterday I was about to tell. Today, class name 2 in which module? Threading module. What is the class name? Lock. In that, step number 1 is called what? Create an object of lock class. Create an object of lock class. I'll tell you that. Create an object of lock class. How do we create an object of lock class? L is equal to threading dot lock off. It's the meaning of locking actually. When I'm having 3 threads, T1, T2, T3 threads are there. When all of them starts at the same time, they are entering into where? Same function. They executed, work done, and the work done result is what? Wrong result. That is called what? Deadlock. In your colleges, Shahid, in colleges example, textbook example I am telling, which I studied, which you studied. Still, yesterday night I seen, still the same textbook is there for you also. Meaning students are same textbook, same textbook, same textbook, same topics are there even for engineering syllabus. What's up? Which I studied, still it is available like this. Processor one, processor P1 means a thread T1, processor P2, processor P2. These are the two processes. To complete these two processes, there is a resource R1. The resource R. There is a resource R2. There is a resource R2. Breaking. There is a R1. Resource R. Is it okay? Why is coming fast for? Due to net issue, not getting everything all going in a garbage collector. Everything all are going to garbage collector. Okay now, but no guarantee. Fast and repeatedly. So time waste and rest and this now. All time waste, knock time waste, ఊరికే కూర్చో. So students wait for 2 minutes. Wait for 2 minutes. Voice is being overlapped. Wait for 2 minutes. Not able to understand anything, sir, because of breaking voice. Today class is totally disappointed, sir. Okay. Today class not disappointed. Net connection is disappointed. What to speak also don't know. Voice. I am not speaking. Wait for 3 minutes. I am also waiting for 3 minutes. Meantime, I'll ask some questions. So I'll ask questions. Boys or girls are first? Boys are. Boys. First I will start with you. Your friend. Ladies first, sir. Okay. Because of ladies first only, no bus stops are full complete first. So, so last questions. You will answer. Okay, students, they are not even looking at me. Because when I say asking questions means they will get lot of trouble. When you go to interview, how you will answer? So, time my pen. Already I gave some holiday for you. Some holiday I gave again today. Working day, but no class. So I think they will give your book to read. I think they will give your book to read, okay, to the interviewer. Is it like that? Is it like that? Rejoin may help, huh? Okay. Students, shall I rejoin? Shall we rejoin all of them? Shall we rejoin all of them? Hmm? Rejoin చేపిద్దాం ఒకసారి అందరినీ. Rejoin. Okay. So students, all online students, rejoin. Rejoin faster. So you do faster. Rejoin. All of you rejoin.